Hello everyone. A very good evening to one and all of you. I hope I'm audible and visual. So let's wait for 5 to 10 minutes so that everyone can able to join this session. Okay, let's start the session. Hello everyone, my name is Pooja Verma. I am PMRF Research Scholar from IIT Kharagpur, and the instructor for this course is Professor Syamal Kumar Das Mandal from Advanced Technology Development Center, IIT Kharagpur. This is a week 5 live and interactive session on signal processing techniques and its applications. You can use chat box for asking and interacting. So I hope I'm audible and visible. So this is the course content for this week. I hope all of you have gone through this week video lectures. Okay. So first we will go through some theoretical concepts, then we will solve some numerical problems which will be very similar to your assignment problems. Okay, so that you can able to solve your questions. So this week course content is related to properties of the discrete Fourier transforms and linear filtering. And in the linear filtering, overlap overlap save method and overlap add method. Okay, so already you know that in the previous week we have taken the discrete Fourier transform. So discrete Fourier transform are defined for a finite duration signal. Okay, so it is expressed by x of k, that is this one, and it is equal to summation of n belongs to 0 to n minus 1 x of n e to the power minus j 2 pi by n k n, where k varies 0 to n minus 1, where n is the length of the DFT. Okay, length of DFT, and the DFT provide discrete frequency representation of a corresponding x of n, and the inverse DFT can be calculated by this equation. Already we have converted the original signal x of n to x of k in the frequency domain. Now how we can recover that signal? So to recover the signal, this is the formula, that is x of n is equal to 1 by n, and the summation where k varies 0 to n minus 1 x of k e to the power j 2 pi by n k n, and DFT is computed on using the fast Fourier algorithm. Okay, so this is a method of calculating DFT. Fast Fourier transform is an algorithm to calculate DFT. It is not a method. Now next one is the properties of the DFT. So already you know that there are different properties of the DFT, that is the linearity, periodicity, time shift, frequency shift, conjugation, time reversal, Parseval's theorem, circular convolution, duality, and differentiation. So these are the some properties already we have discussed in the previous week. So this is already you know that what is a linear. It is a follows the superposition theorem, which is a additivity and homogeneity property. It follows the additivity and homogeneity property. So if there are two signals x1n and x2n in the time domain, it will be the multiplied and then added, multiplied by some constant and added, then corresponding frequency domain signal will be the same. The x1k is the DFT of x1n and x2k is the DFT of x2n. Okay, it will be the same. It follows the linearity and homogeneity, additivity and homogeneity property. Similarly, for periodicity, the signal is shifted by endpoint in the time domain, corresponding in the frequency domain, it must be shifted by the same phase shift. Okay, in the corresponding frequency domain. Then time shift, if there is a shift in the time domain by a constant n naught, then it will corresponding shift in the frequency domain in the same way. That is xk is the DFT of x of n, then e to the power minus j 2 pi by n k n naught is the shift, n naught is the shift corresponding a frequency domain. Okay, now next one is a frequency shift. Corresponding frequency shift into in the frequency domain. Okay, then conjugation, if any signal is conjugated in the time domain, then it will be corresponding the corresponding frequency in the frequency it will be the n minus k, x conjugation n minus k. Now next one, if there is a convolution in the time domain, then similarly it will be the multiplication into the frequency domain. Okay, so these are the some important properties of the DFT. We will solve some numerical problems, so you will understand in a better way. Now next topic has been covered for this week is linear filtering. So what is a linear filtering? So linear filtering is a fundamental signal processing operations where an input signal is modified by a linear system, which is represented by a convolution with an impulse response. It is commonly used for smoothing, sharpening, noise reduction, and feature extraction in signals. Okay, so suppose the input signal or input sequence x of n of a there is a long duration input sequence x of n. Something is to be processed with the system. So how we can process? So first we have to just break into small using DFT, endpoint DFT, finite duration impulse response by convolving a finite duration impulse response. Since that linear filtering is performed via DFT, so that involves the convolution operation. Okay, so what we generally do, we divide that long sequence signals x of n into a finite duration sequence by doing the convolution operation, then convert it into a frequency domain, that is DFT, then take in as a inverse DFT to follow to get the same signal. So for a discrete time system, the output y of n of a linear filter with an impulse response h of n and input x of n is given by this one. Then this is a convolution operation that we know that. So linear filtering can be performed by two ways. First one is a overlap save method, and second one is a overlap add method. So in the overlap save method, so it is said to be it is an efficient way to perform long sequence convolution using the fast Fourier transform. So instead of computing a convolution directly, which which is a computationally obviously expensive, the input signal is divided into overlapping segments and FFT performed based on that. So these are the some steps to perform to overlap and save method. That is segment the input signal, first divide the input x of n into the overlapping block of size n, then each block will be overlapped in the last m minus 1 zeros added, the m minus 1 zeros has been padded, then FFT will be computed for each block using FFT filter h of n. Okay, then multiply in the frequency domain with, because whatever the convolution into the time domain, we know that simply multiplication into a frequency domain. Then again find out the inverse fast Fourier transform, then whatever zeros we have padded m minus 1, then just remove that from the each block or by adding these corresponding blocks. Okay, I have you have seen in the video lectures already, so how they have performed in that form. Just we will divide some, then add some, pad some m minus 1 zeros, then discard them. Okay, now next method is overlap add method. Okay, so in the overlap method is another way to perform the or the linear filtering. It is also a FFT based convolution technique only. So that it is used to input into non-overlapping segment and process it separately, and these are the some steps which is performed in overlap and add method. So first, same, segment the input signal into a n or the L length non-overlapping blocks, then pad 0 pad at each block, pad each block with m-1 zeros to match FFT with size n. So let's see it in long sequence. We will first divide into a L length, then add some zeros at the end, m-1, and then apply FFT, then multiply in the frequency domain by taking the converting into both in the frequency, that is performing TFT. Then take inverse transform, then overlap each region and add the successive blocks. Okay, so these are the some topics which have been covered for this week video lectures. Now we will solve some problems which will be similar to your assignment question. So first question is, if x of n and x of k are the 8-point DFT pair, then what will be the x44? So you have any guesses, or can you suggest me how to solve it? Then I will solve it. First try to answer for this question. Which option can be a correct one? Please try to solve this question. Yeah, anyone of you solving these questions? Yeah, that is x of 4. Okay. So how you have solved this question? Okay. So I'm explaining it here again. So it is given x of n and x of k are the 8-point DFT pair. That is x of n. X of k is the DFT of x of n, and it is given n is equal to 8 point. It is a 8-point DFT. Now x44 will be equal to at which value? Okay. So yeah, someone is, yeah, correct. So the DFT of a periodic with period equal to the number of points in the transform. So already we know that the periodicity property of the DFT, periodicity property of DFT, that is x of n plus k is equal to x of k, or also we can further write it x of r into n plus k is equal to x of k for all k. Okay, where r is the integer value. It can be any integer value. Okay, so it is given, it is a 8-point DFT. That means if DFT is periodic with 8, so we can write it 8 plus k is equal to x of k. So we need to find out, to find x44. So at which integer value if we multiply, then we will get the 44. So if we 5 into 8 plus 4 if we will do, so this is r, it is an integer value. Okay, so it will be the equal to like this, r into n, n is k, right? So it will be the equal to x4. Okay, or otherwise you can do, it is a 44, right? And there is n point DFT. If you just divide it to 8 5s are 40, then only 4 left. Okay, then this one. Otherwise you can do like this way. So x 44 will be equal to the x of 4. Okay, so correct option is option D is the correct answer for this question. So now moving to the next question. If x1k and x2k are the endpoint DFTs of x of n1 and x2 of n respectively, then what is the endpoint DFT of xn? That is equal to 3xn x1n plus x2n. If which option will be the correct for this question? Yeah, Kavita, that is correct. Okay, so here which property we need to apply? Yeah, it follows the linearity property. Correct, correct. Okay, so here it is given x1k and x2k are the endpoint DFTs of x1a, and that means x DFT x1 and DFT is x1k and x2's DFT is x2k. Right, now we need to find out then what will be the DFT of xn is equal to 3x1n plus x2 of n. Okay, so from the linearity property, as we know that linearity property a x1 of n plus b x2 of n, that is a x1 of k plus b x2 of k. Okay, as we know that. So similarly for what will be the 3 x1 of n plus x2 of n. Already we know that x, what is the DFT of x1n and x2n, and this is a constant or integer value. Yeah. So the respective DFT will be 3 x1k plus x2k. Okay, because it follows the linearity property. So option B is the correct answer for this question. Okay, so I hope all of you are getting. So moving to the next question. Now next question is the first 8 point of a 8 point DFT are real sequence are, that is 8 2 plus 3j plus 12 in comma 3, 36 minus 24j 5 36 plus 24j and x y. The value of x and y what are respectively. So what will be the value of x and y? How we can calculate it? So already we have solved in the previous week this type one question this type. So can you answer for this question? What will be the values of x and y? Okay, 2. Okay, yeah, correct one. So here already given the it is a 8 point DFT, that means n is equal to 8 Option D. Okay, let's see. We will solve it. So here already it is given n is equal to 8 point and 8 points are given. That means it is related to at 0th position. It is 1, it is 2, it is 3, it is 4, it is 5, it is 6, it is 7. Okay, so that means we need to first find out that at the position what will be the value of at the position of 6th and 7th. Okay, so the whatever value will come at 6th position, that is x, and whatever value we will get at 7th position, that is y, right? So so already we know that from the property of a DFT, a sequence x of n is conjugate even periodic if conjugate even periodic if x of n equal to x conjugate n minus n. Okay, so already we have 0 to 6 5 points. 6 and 7 we need to calculate. So at the 6th position, the whatever value will come, that is x. So first we will calculate x of 6 is equal to x conjugate n is 8 point DFT. So 8 minus 6, right? So x conjugate 2. So whatever at the position of 2, that will be conjugated. So here the value of at position 2 is 12. So it is a real value only. If there is imaginary, so it will be the opposite one. So it is a real, so it will be 12 directly. So x of 6 at position 6 we will get 12, which is equal to x, value of x. Okay, so x we have got 12. Now we have to calculate y, that means at 7th position. So x conjugate 8 minus 7, which is a x conjugate of 1. Okay, so at 1 position, what is the value? 2 plus 3j. Now we have to conjugate. So conjugated value will be 2 minus 3j, right? So it is equal to the value y. Whatever value we will get at 7th position, that is equal to y. So x is equal to 12 we have got, and y is equal to 2 minus 3j. Okay, so which option is correct? So option C is the correct answer for this question, not D. Okay, so I hope you have understand this question. Okay, okay, so moving to the next question. Now next question is, if a sequence x of n is real and even sequence, then DFT of a given sequence is. Which option will be correct? Option A, option B, option C, or option D? So here it is given x of n is real and even sequence. Then what will be the DFT of that sequence? Okay, option B. Yeah, correct. Option B is the correct answer. But how? I will explain it here. Okay.
Sine, cosine is printed two times.
Yeah. Here actually sine and cos are printed. So
Yeah,
it is only one time only. Okay.
yeah.
So
Okay.
here by mistake it has been printed by two times. So it will be the one only in all the equations.
Uh, Excuse me, ma'am, can I ask one doubt?
Yeah. You can ask. Yeah.
Actually, in assignment, there are two questions where the answer is not matching. In assignment 5 it seems. Question number 7 and question number 10. Can you see to it afterwards?
Yes, the questions are entirely different with respect to the given options. They are not
Yeah,
matching
yes.
the options.
Yeah.
We tried in so many ways by using the
Yeah.
formulas
That's
and
why we
using
just
fast
wanted to know
Fourier
what.
transform.
Yeah.
So the questions are not correct for
What will be
both
done for
seventh and
that,
the
sir?
last
As
question.
That we need to see actually. Hello. Okay, I will check that questions. Okay, we will check that questions
later,
and
just
if
clarify, ma'am. No issues. Just I wanted to inform.
we will
Yeah.
complete it.
Yeah. Yes, ma'am.
Yes.
Otherwise, actually,
Just
I
wanted to
can't do
bring to the notice.
anything
That's
in that question related to that questions. Whatever is given, you have to solve
Yeah.
this question. Otherwise, you can raise the doubt there. Okay, there is a mistake.
Where we can. Yeah.
I think then they can. I mean, correct it if there is any problem in that related to
Where
that.
we can do that, ma'am? That's why I wanted to know because I didn't get any means to tell that.
Oh, okay. No, there is a one.
Because after the completion of the given, after giving the assignment questions, they can't change it, no?
Yeah, that's
Uh,
what would be done for that. I just wanted to know.
Is there is
okay.
any grace marks or only the marks is covered only for 8? Because two
Maybe.
questions are entirely wrong.
Okay, two questions are inter. Okay, so
Yes, the
we need
question
to.
number is
There
7
is
and the
a. I
question number
think
is
there is
10.
a question
And
forum. Something is there, na doubt forum type. There you can ask or raise
okay,
your doubt.
discussion forum.
I will tell you the question. I will tell you the question.
No, it's okay, sir. I think in discussion forum we can put the
Yeah,
same
from
thing. I
discussion
don't know because
forum
that's
you
why I
can take.
didn't.
Otherwise, I can ask from the faculty, but it's
Just
started.
bring it to the notice, ma'am. That's all.
Okay. We will check
Because
that
if it is
question.
like that means you will feel somewhat difficult to solve that one for more amount of time. We
Okay.
solve in different times, different methods, but there is no answer for that question itself.
Okay, maybe that mistakenly that have been gone. So we will check that. Otherwise, I can ask that. Otherwise, you can raise your doubt in the discussion forum also. I will do that on the behalf of that. We will check it.
The question number is 7 and 10.
7 and 10. Okay, question number 7 and 10. Okay.
Yes, in assignment 5. In the
Yes,
assignment
ma'am.
5, 7 and 10 or the questions are not matched or the answers are not
Answers
matched
are
with
not
the given
matching.
questions.
Okay. Assignment 5, right?
Yes,
Yeah, yes,
assignment
ma'am.
5, question number
Just bring
7
it to
and
the
10.
notice. Yeah. We just wanted to tell that. Yeah. Thank you very
Okay.
much.
We
Sorry
will
for
check
Thank
that.
you.
disturbing.
Okay.
Yeah.
Can you tell me what is the last date for submitting your assignment?
Maybe it is
Next Wednesday, next Wednesday,
24th.
next Wednesday.
Next
Okay, then.
Wednesday. Okay. I don't know.
Okay.
Okay.
We will check it.
Is there any, there will be any message for us if there is any modification in the questions?
I
Because
think
once we have completed means we can't go through that one because we have so many multiple works like that. And we
okay.
must
I
also
think
hear the videos for the respective next upcoming week also.
yeah, right. I think in that case you need to check in the assignment itself. Maybe changes directly made will be there. Otherwise, what I can ask the faculty and other TAs. So I will inform them if there is anything. Otherwise, they can do in the discussion forum. We will update there. Otherwise, where there is one place where you get all the notification, right? You can check NPTEL that notification in this subject only.
Okay, ma'am.
Okay, we
There we
will see
will
that
update
one.
that.
If not means, please do favor in for us.
Okay, in that case, you will get
Because
grace
already
marks. You will get.
we saw the same problem in the previous assignment in the previous subjects what we had enrolled there. For
Okay,
example, if the question is wrong means they had removed that question and they had given only for the remaining questions.
okay. In
So
that
what I
case,
thought today also like that only.
okay, I will inform them from my side. So if they will correct it directly in the assignment also, otherwise there is some solutions will be there. Otherwise they will give grace marks or cut down that question also in that case.
Okay, okay. Thank you, madam.
Okay, okay,
Thank you, ma'am.
yeah. So here it is given that sequence x of n is real and even sequence. So what will be the DFT of the corresponding signal? So if the sequence x of n is real and even, then its DFT must be following this property. That means the DFT x of k is real value. That means it has no imaginary values. Okay, it has no imaginary values or imaginary components, and the DFT consists only cosine terms, not a sine term. Because the sine terms will be cancelled out. If you have seen the whole equation, there are equations are given, four equations for real and even sequence, real and odd sequence, imaginary and even sequence, imaginary and odd sequence. So from the whole derivations, you will get that. So in that sort, I am just giving the hint. It has no imaginary components in this equation, and there will be the DFT will consist only of cosine terms. T will consist of cosine terms only. So for DFT of a real and even sequence, DFT of real and even sequence must be. So if we go through the options only, so it contains the sine terms, so it cannot be a real and even sequence because sine terms contain the odd frequency components. Okay, so next option is option B, that contains a cost term. So it can be similarly, and this option C and D is not a DFT, it is a inverse DFT because 1 by n terms will be there. Okay, so these two are cancelled out, IDFT. So only what left? Option B. So option B is the correct answer. If you have less time and you want to sort it out, so in that case just check, go by options, which options can be a correct one. So from here we can see that option C and D are the equations of inverse DFT. So it cannot be correct because they have asked only for DFT. What will be the DFT? And by just looking these two properties for real and in sequence, so we can see that only option B is the correct answer for this question. Otherwise, other way you have to solve the whole equations. Okay, so already you have gone through this video lectures. So there are four equations. Then they have considered what will be the real and even sequence, what will be the real and odd sequence, what will be the imaginary. Okay, so just in that case, you have to write the whole equations and put imaginary part equal to 0. Then you will get the real sequence. What will be the real sequence for the DFT? So from here, option B is the correct answer. Okay. Okay. Already you know that. Moving to the next question. So now next question is also related to this only. If a sequence x of n is imaginary and odd sequence, then the nature of the DFT of given sequence is will be. What is option? Options are purely real, or option B is purely imaginary. Option C is both real and imaginary. Option D is none of them, or none of the above. So which option can be a correct one? Can you answer for this question? Please answer at least in the chat box so that purely imaginary. how you are getting purely imaginary? Because they are asking if a sequence x of n is imaginary and odd sequence. Okay, not a imaginary even sequence or like that. Option C, both real and imaginary. Okay, we will see. So yeah, how we can you, have you make only guesses or have you solved these questions? Option D, none of the above. Okay, okay, let's see. So here they have said that if a sequence is purely imaginary and odd sequence, symmetry property. Okay. No, no, not from there. Actually, they are saying that if a sequence x of n is, we know that x of n is a combination of real and imaginary, x of r plus x of imaginary n, right? So have you seen, you have been seeing in that video lectures also. So if a sequence is imaginary and odd sequence, then DFT of x of n is x of k must be a purely real. So how it can be? Because first we will go through imaginary part, then we will take odd sequence. Okay, we will consider both the terms, then I will describe it, because a sequence can be made, and then similarly the DFT will be x of k also equal to the real part and imaginary part xik, right? Now if they are saying if a sequence x of n is imaginary and odd sequence, then the nature of DFT, what will be the nature of that DFT of a sequence? Okay, so if let's say that x of n is equal to j xi of n, that means they are saying that it is j also imaginary. First we will consider the if a sequence is imaginary, then and odd. Okay, and odd, that means x of minus n must be equal to minus x of n, right? So they are saying that that means real part will be the 0 only, x of r of n will be 0, because they are asking for imaginary and odd sequence. Similarly, then the DFT will be the, already we know that it is a the complex, DFT will be the complex also, it contains both real and imaginary part, right? Then if we take these two, so a DFT will be also the imaginary only, x of k must be j xi of k, because x r of n equal to 0, so x r of k will be 0, the real part will be 0, because we are finding the imaginary and odd sequences only, right? Now will be the imaginary. Okay, so x, and if we are taking the odd sequence, x of minus k will be, so minus j xik will be only, because of odd sequence, the that property x odd sequence. Okay, so now from the equations, if we see in the terms of cos and sine term, what will be the part x, if we if you write both the equations, then you will get like n is equal to 0 to n minus 1 x I n, the real part, and imaginary part if we are writing it sine 2 pi nk divided by n, right? So if we take, for example, what we'll do, sine of minus theta will be minus sine theta, okay, and cos of minus theta will be the cos theta only, Already we know that this part. So if we write the whole equation, that one, it is a real part, and then we will write, so it will be the odd only. So if we sine of minus theta minus sine theta will be there, okay, the real part will be odd. That means, but here the real part is 0, so we don't need to consider the real part. Now if we consider the imaginary part, that's what will you will get. Just a minute. If you will consider xi of k summation x is equal to 0 to n minus 1 x of n xi of n cos 2 pi kn divided by n. Already we know that if we take this property, so a cos of minus theta will be the cos theta only, so there will be the no minus sign only. Cos 2 pi by kn divided by n. Okay, so what we have got, this is a purely real only, right? If you write a whole equation xrk, then sine plus x, putting xrk in as a real part will be 0, and just taking that this sequence, we know that x of minus n is equal to minus x of n. So if we put minus in all the places, you will get cos of minus theta will equal cos theta. So what equation you are getting? You are getting the same equation. So what will be the nature of the DFT of the imaginary and odd sequence? Will be the purely real, not a purely imaginary, because we are not getting here, we getting the cosine term. That means this is a not a odd, this is a even function, right? So you will get only purely real, not a purely imaginary. Okay, if you are putting all these things in that equation. So first you need to take the real part, then put it, then you have seen that minus sine theta, so it is odd, and if you put x r k equal to 0, that means the function will be the 0. So only odd, if now you are applying the odd part in this, so you are getting cos theta only, so no minus sum and these things, so you are getting only the purely real, not imaginary, so no imaginary part will be there. Xik, if you are further putting xik values, so minus that j will be the cancelled out only, so you will get only real part, purely real, if you are putting these two conditions in that equations. Okay, so option A is the correct answer, not the B. So have you understand this question? Anyone of you have any doubt in this question?
No, ma'am.
Okay, so have you understand how it is coming only purely real, not a purely imaginary?
Yes.
Okay, okay. Moving to the next question then. Now next question is, consider a sequence x1n, that is 0, 1, 2, 3, 4, and x2n, that is 0, 1, 0, 0, 0. Determine the sequence y of n such that yk is equal to x1k and x2k. So already we know that in the frequency domain, they both are the multiplication simply, where x1k, x2k, and yk are DFT of x. These sequences correspond x1n, x2n, and yn then respectively. So how we will get the y of n? Again,
First of all, we can take the values of x1 of k and then x2 of k. So if
okay,
you multiply both, we are going to obtain the same value, that is nothing but the value of x1 of k. Again, if you take inverse Fourier transform, or by using the inverse past Fourier transform, the value of x1 of n is same.
Okay, so how
In that way, simply.
okay, so first you have to calculate x1k from x1n, then you have to calculate x2k from x2k, then you again you have to multiply in the frequency domain, again you need to convert into a time domain. So how you can solve this type of problem? Yeah, directly we can't get it from here. So sir has given one concept, circular convolution. Okay, so we will solve this problem through circular convolution. Okay, because directly we can't calculate, because it is also a 5-point DFT, right? So if you calculate, it is a very long process in that case. So first you can get it from there also. First calculate x1k, then x2k, but it is very long. So if you want to calculate it directly, so there is one concept you have studied must be circular convolution. So x1n, the circular convolution will be represented by this sign, right? x2n. So it is similar to the convolution only. If you want to find out the yk, so same as multiplication into the frequency domain. Now, if you find out the circular convolution, then it will be, the equation will be like this: m is equal to 0 to n minus 1 x1 n or x1 m into x2 n minus m mod n. Okay, here n is given as 5, right? So circular convolution, in order to calculate, there are simply two ways to calculate circular convolution. One is matrix multiplication method. Second one is a direct formula method. Okay, just you can directly calculate from the formula. So I have added one slide for that to calculate the circular convolution. So one way directly you calculate from here only. Okay, just take that all the points, but this is the effective way to calculate the circular convolution. If it is a 4 till 4 point, you can, if it is a till 4 point, you can directly calculate from this equation. If it is more than 4 points, then it is very difficult to calculate using direct method. More than 4 points, let's see 6 7, then it is very difficult, then use a matrix multiplication method. Okay, so I will tell you what is how to calculate using the matrix multiplication method, the circular convolution. So I'm writing it here. So first one is a direct one. So from there you can also calculate, but matrix multiplication method will be the easy one. Okay, so in the matrix multiplication method, if there are two sequences, yeah, option E is the correct answer. Okay, we will see that. So if there are two sequences, then make a matrix from one sequence like x2 or x1 and here. So first I am taking x1 and in the first matrix. So just simply write 0, 1, 2, 3, 4. Now what we are doing, just shift by one place. Okay. So just take this last one to the first and then write this sequence 0, 1, 2, 3. Again take last value to the first, in the third column again just write. So 4, 0, 1, 2. Again take it here 2, then again write from here 3, 4, 0, 1. Okay. Now again take, it is a 5 point, so there must be a 5 column. and 5 rows. So 1, then 2, 3, 4, 0. Now this matrix has been completed. Okay. Now what we need to do? We need to take the another value. So just 0, 1, 0, 0, 0. Now just calculate it. X to n. So it is the simplest way to calculate. Now same way, just multiply row with the column, add this. Multiply, add. Okay. So 0 into 0, 0 plus 4 into 1, 4. Then 3 into 0, 0. 2 into 0, 0. 1 into 0, 0. Okay. Now next one is 1 into 0, 0. 0 into 0, 0. Again, all the three values are 0, so we will add 0 only. Okay. Now next is 2 into 0, 0. 1 into 1, 1. Again, all the three values are 0, so whatever the value will be 0 only. 0 plus 0. Now next will be the 3 into 0, right? 0 plus 2 into 1, 2. Now next three values are 0 because all these values are 0. Now just multiply last row to this column. So 0 plus 3 into 1, 3. Again, all these values are 0, right? Now add. So 4 in this row, 0 in this row, 1 in this row, 2 in this row, 3. So you will directly get equal to y of n. So 4, 0, 1, 2, 3. So finally you will get here 4, 0, 1, 2, 3. You can cross check it using the direct method also. You will get the same answer. Okay. So correct answer is 4, 0, 1, 2, 3. That means option A is the correct answer. So have you got this question? To how to solve this type of question? Yeah, have you got this question? So other way is
Yes, ma'am.
also there is a circular. Just make a circle and calculate from here. There some steps are required. Okay. So from there, but it is a more than 4 points. So from this we can't calculate because here it is a 5-point DFT. So best way to calculate the circular convolution is the matrix multiplication method. Okay. Okay. So I hope you are getting. So moving to the next question. So now next question is, let the discrete time signal be a signal given as x of n with DFT x of k. The DFT of a circular time shift x n plus m and that mod n can be expressed as. Can I ask whether this question is in your assignment problem or the different one?
No, that is different one.
Okay,
7 is
different.
not this question.
Okay, okay then.
They have given a sequence and they have given the DFT and they have asked the questions. That is wrong actually.
Okay, okay.
Not this question.
Okay. So can you answer what will be the correct option because it is from the time shifting property of the DFT. So x of k is the DFT of x of n. Then what will be the DFT of x n plus m? So already we know that the DFT of a signal x of n can be calculated by this equation, right? N is equal to 0 to m minus 1 x of n e to the power j 2 pi minus kn divided by n. Right? So now at the place of x of n, we need to get x n plus m, but we directly cannot be calculated. So just put n plus m is equal to m, small m, right? Let here n varies 0 to n minus 1. Now if we put m is equal to n plus m, then what will be the m varies from? Then m varies from capital M, okay? Because n is equal to 0, if you put n is equal to 0, so capital M will be the small m 2. If you put n minus 1 in place of here, so you will get small m n minus 1 plus m, right? So now let's x1k is the shifted version TFT of that shifted signal, okay? So now here it varies m is equal to 0, sorry, capital M to n minus 1 plus m, right? X of m, just put in place of n, that is m, e to the power minus j 2 pi k divided by n, here m minus capital M. Sorry, in place of n, we are putting m minus capital M, small m minus capital M, right? So further, if you, I'm writing it here. So further, if you expand the equation, so you will get m is equal to capital M, n minus 1 plus m, x of m, e to the power minus j 2 pi k m divided by n into e to the power minus, and minus this will be plus 1, j 2 pi k because it is common, n into capital M. This minus will be the plus only. And already we know that this will be the equal to x of k. So x of k e to the power j 2 pi k capital N into M. Okay. So this is the shifted version of the xn plus m. That is option C is the correct answer. Xk e to the power j 2 pi k m capital M by n. Okay. Okay, so I hope you have got this question. So moving to the next question. So now next question is, if x of n is a real 5-point sequence and 5-point DFT is x of k, where x of 0, x of 1, x of 2 is given, then determine the what will be the value of x of 0. What will be the value of x of 0? Can you answer? Okay, here already given, it is a 5-point DFT. So n is equal to 5. X of 0 is given, that is 2. X of 1 is given, that is 2 plus 3j. X of 2 is given 4 minus j. Now it is 5.23, 4, and at the place of 3 and 4 are left, right? Yeah, correct. So now we need to calculate the x of 3 and x of 4 in order to revert back this signal. So already we know that the conjugate given periodicity property, conjugate property x of k is equal to x conjugate n minus k, right? So x of 3 will be equal to x conjugate 5 minus 3 will be x conjugate 2. So whatever the at position 2, that will be the conjugated of value of x of 3, 2 minus 3. So at a place of 2, x of 2, sorry, x of 2 is 4 minus j. So that will be the 4 plus j. Conjugated value of x of 2, that is 4 plus j. Okay. Similarly, we need to find out x at the place of x of 4, that is x conjugate 5 minus 4, that is x conjugate of 1. So what is the value x of 1? That is 2 plus 3j. Then conjugated value of 2 plus 3j is 2 minus 3j, right? Now we need to find out x of 0. Okay, that means we need to take the inverse DFT, right? So from IDFT, inverse DFT, we know that the formula x of n is equal to 1 by n summation k varies 0 to n minus 1 x of k e to the power j 2 pi kn n, right? So now we need to find out the x of 0. So at a place of n, we need to put 0. So to find out x of 0, so just put at a place of n is equal to 0. So 1 by n, capital N. So it is a 5 point, so 1 by 5, and k will vary 0 to n minus 1. So n minus 1 is 5 minus 1, that is 4, right? X of k e to the power j 2 pi k by 5. Here n, so n is 0, so then this will be 0. So e to the power 0, and e to the power 0 will be 1. Okay, so we will get 1 by 5. K is equal to 0 to 4 x of k. That means simply it is a 1 by 5 addition of x of 0 plus x of 1 plus x of 2 plus x of 3 plus x of 4. Okay, so I'm remove it from here so that we can write. So simply add all these values. So x of 0, what is the value? It is 2. What is the value of x of 1? It is 2 plus 3j. X of value of x of 2, that is plus 4 minus j. What is the value we have got the for x of 3? That is 4 plus j, plus what is the value of x of 4? That is 2 minus 3j, right? Now this plus 3j minus 3j will be cancelled out, and here plus j minus j will be cancelled out. Now add all these values. So 2 plus 2 4, 4 plus 4 8, 8 plus 2 4, 12 plus 2 14, right? Yeah, so it will get 14 by 5. So which option is correct one? Option D is the correct answer for this question. Okay, so I hope all of you have got this question. So moving to the next question. Now next question is from the above problem, that means question number 8, the energy of the sequence will be, what will be the energy of the sequence? Okay, so already we know that from the Parseval's theorem, from the Parseval's theorem, 1 by n is equal to k varies 0 to 1 minus 1 mod x of k square. Okay, that is represented by energy. So already we know that all the values 1 by 5 and the k varies 0 to 4 x of k square. Okay. Now open the summation and put all the x of we can say that x of 0 square plus mod x of 1 square plus mod x of 2 square plus mod x of 3 square plus mod x of 4 square, right? Now put all these values. So what is the value of x of 0? That is 2, right? So 2 square. So 2 square, I am directly writing here. 2 square is equal to 4 plus what is the value of x of 1? So x of 1 is 4 plus j, I think. No, 2 plus 3j. So mod 2 plus 3j square. So it will be the root of 2 square plus 3 square, right? Already we know that. So it will be 4 plus 9. So root of 13. Okay. So root of 13 square, right? So root of 13 square will be the 13 only. Similarly, x of 2 value is 4 plus j, right? So 4 mod of 4 plus j will be the 4 square plus 1 square, real part square plus imaginary part. So 17, root of 17, its square will be the 17 only. Similarly, x of 3 is 2 minus or plus 3j. So it will again give 13 plus 17 if you further calculate it. Okay. Now if you further add all these values, you will get 64. 64 by 5. So energy of the sequence will be 64 by 5. So option B is the correct answer for that question. Okay. Okay. So have you understand this question? Can we do okay? Moving to the next question. So now next question is consider the following statements for endpoint DFT xk for a real value discrete time sequence xn. Which of the following statements are true? Which statements are true? Option A is x of 0 equal to summation n values 0 to n minus 1 x of n, or option B x n by 2 equal to n values 0 to n minus 1 minus 1 to the power n x of n for n being even, or option D x of k is equal to x conjugate n minus k, or option D are all of the above. Which option will be the correct one? Can you answer for this question? Yeah, option D. Okay. Okay. I will explain here by options. So we will see which one is correct. So already we know that DFT, equation of the DFT, x of k is equal to n varies 0 to n minus 1, x of n e to the power minus j 2 pi by n k n, right? So option A, whether it is correct or not. Okay, yeah, Kavita. So first we will see option A, x of 0. What will we get? So already we know that it will be n is equal to 0 to n minus 1, x of n e to the power minus j 2 pi by n into k n. Here k is equal to 0, so e to the power 0 will be 1 only. So we will get n is equal to 0 to n minus 1 x of n. That means option A is the correct. Now we will check for option B. So option B, they are saying for n being even. If n is even, what will be the equation? Whether this equation will be satisfied. So already we know that if we take k is equal to 1 by 2, that means because it is even. Now n is equal to 0 to n minus 1, x of n e to the power minus j 2 pi by n. Here we have said that n is even. Okay, so in place of k we will put n by 2 into n, right? So 2 will be cancelled out, n will be cancelled out. So here what we will get, n is equal to 0 to n minus 1, x of n, we will get e to the power minus j pi n, and already we know that the value of e to the power minus j pi will be minus 1. Okay, so e to the power minus j pi n will be the x of n minus 1 to the power n, and summation n varies from 0 to n minus 1. So option B is also the correct one. Okay, because they are giving this condition for n being even. Okay, now option C, we know that by the conjugate property x of k, already we have used many times, x conjugate of n minus k, it is also so all of the above. So all the statements are true. So option D will be the correct answer for this question. Okay. Okay, so we have solved this question. So moving to the next question. Now next question is, if x1k and x2k are the endpoint DFTs of x1n and x2n respectively, then what is the endpoint DFT of x1 is equal to 2x1n plus 5x2n? So already we have solved this type of problem, so you can answer for this question. So this question is also related to properties, or this is, you can say that it is a live and interactive session. So this is a practice questions for you related to properties. D, no, it's not D. So just take the linearity property of the DFT. Okay, so already we know that x1n, DFT of x1n is x1k, it is given, and DFT of x2n is x2k. So what will be the DFT of xn? That is given as x2 x1n plus 5x2n. So already we know that by the linearity property, a x1n plus b x2n, DFT will be a x1k plus b x2k, right? Similarly, it is same. So 2 is an equal to a, that means constant, x1n plus 5 x2n. DFT will be 2 x1k plus 5 x2k. Okay, DFT from the linearity property. So 2x1k plus 5x2k. So option C is the correct answer for this question. Okay. Okay. So now next question that is related to that sequence only, the real and even real and odd, imaginary and even imaginary and odd. But here it is given, if x1 xn is real and odd, what will be the IDFT of the given sequence? What will be the inverse DFT? Here it is given real and odd. Okay, so if x of n is real and odd, then we know that x of n will be the minus x n minus n, right? And x imaginary and odd, no, here it is given as real and odd. Okay, so there are four parts. It can be real and even, real and odd, imaginary and even, imaginary and odd. All the four we have to check. Okay, so here it is given. Okay, so here x r k will be 0 because it is odd. So x of k will be here will be purely imaginary and odd. Okay, so here the real part reduces to 0 and IDFT reduced to 1 by n because it is IDFT, so 1 by n will be there into j x of k sine 2 pi by n k n, where k varies 0 to n minus 1. Okay, so in that PPT also you can see there are four parts. Okay, so if you further solve this by taking the real and imaginary part, then you will put the real part equal to 0, then you will get this one, imaginary and odd. So sine of minus theta will be the minus sine theta will be there. So already we know that if you put, we will get minus, so it will be the inverse DFT, you will get this cosine term, not a cosine term. Okay, because it is a odd function. So option A is the only correct answer for this question. Okay,
Excuse me, ma'am. Is it
yeah,
x of n or x of k in the question?
x of
If
what
x
is
of k is real and
x
in the
of,
question, it is written
yeah,
as
yeah,
x of n is real and odd. Is it x of k or x of n?
x of k only, because they are asking what is
K, yeah. That
IDFT.
is why.
Okay, okay, they are asking for
If x
IDFT.
of k is real and odd.
It
Yeah,
will
that's
be
why
the
I asked.
yeah,
If
yeah,
x of k is real and odd, then what is the IDFT of, right?
yeah, yeah.
Because
They
we
are
have to
asking
use
if
x of
x
k
of
here.
n is real and odd, then IDFT, inverse DFT.
No,
What is your
here
doubt?
we have to use this x of k's, yeah, property here, no? In the, see, we have the options. We
Yeah,
have to
yeah,
find IDFT of the options,
yeah,
right?
yeah,
It should be
IDFT.
x of k or x of... No, in the question it is given as x
Yeah,
of
yeah, yeah,
n.
yeah. I
That's why
have
I asked.
understand. I have understood. It
It
is
should be,
IDFT, no? So x of k will be in the inside the summation.
yeah, it should be x of k, yeah,
Yeah, yeah. It
in
should
the
be x
question.
of k. Yeah,
X of k.
yeah, x of k.
That's why I got, yeah, wrong answer. Fine, fine. Okay.
Okay. Okay, so moving to the next question. Now, next question is determine circular convolution of the sequence. Sequence is given x1n, that is n del n plus n del n minus 1 plus del n, sorry, n del n minus 2 plus n del n minus 3. x2n is given 2 del n plus 3 del n minus 1 plus 4 del n minus 2 plus del n minus 3. So, what will be the IDFT? So they are asking IDFT, not it is a circular convolution. So they are asking x3 of n, which is a circular convolution of x1n and circular x2n. So how we can find out what will be the x1n sequence? Can you tell me what will be the sequence? From here we can get
All four n's. Four n's.
4,
N, N,
yeah,
N, N.
what will be the value? For example, if we are taking the x2n, so directly we already don't know that del n is equal to 1 at n is equal to 0, right? So here it will be the 2 only, and at place of n is equal to 1 the amplitude is will be the 3, so next is 3. At n is equal to 2 the amplitude here it
Okay,
is
yeah,
given as 4,
yeah.
right? So 4 and here
2
at
and 3.
1. So Similarly, what
0,
will be
1,
there
2,
for
3.
this one? So already we know that del n is equal
0,
to
1,
1.
2, 3.
Yeah. So whatever value of n will be there, right? That will be the n value. So 0,
Yeah.
1,
Thank you.
2, 3. Okay. So here this one is a trick. So most of them there will be the confused. So what will be the n in that place? Okay. So that's why I have taken this question. So I hope
That's a nice question.
you have got this question. So now you have to calculate the circular convolution. So how we can calculate x3 of n? So we will solve the another method. Okay, this one x1n. Okay, we know that it is at 0th position, 0, it is 1, it is 2 and 3. Okay, so what will be the, it is 0, 1, 2, 3. Now we have to also take the another one, x2 of n. So it is at 0th position, it is 1, it is 2. So 2, 3, 4, 1. To solve using this method, so the steps that are include, that is 1, plot x1n and x2n. Okay, in this form, circular convolution, circular form. Now next one is take the inverse of x2 of n. That means take inverse. So anyone of you know that this method to solve, how to solve the circular convolution by this, using this? Already sir has told in the lecture video. So take inverse x2 of n, that is minus x2 n, x2 minus n, sorry, x2 minus n. Now shift by one place. Now shift by one place and multiply with x1n. Okay. So these are the steps, shift and multiply and take the values. So now we have plotted x1n and x2n. Now next step is take the x2 of minus 1. So this one is x2 of minus 1, x2 of n. So now plot x2 minus n. So just take the inverse. So 2, 3, 4, 1, right? 2, 3, 4, 1. Now shift, if you shift by 0 first in order to find out x3 of 0. So what will be the x1 of 0? Convolution of x2 of 0. So what will be the x2 of 0? So 0 minus n, right? So x2 0 minus n will be the x2 of minus n only. So just for x3 of 0, just take the multiplication at its places. 0 into 2, 0. So 1 into 1, 1. 2 into 4 will be the 8. 3 into 3 will be 9. So that will come 18. So x3 of 0 will come 18. Okay. So let's write somewhere. Here I am writing x3 of 0 is equal to 18. Okay. Now shift by one more places. That means 1 minus n. Okay. Then again multiplied with x1n and write it down. So what value you will get? Any one of you solving? So just make another circular diagram. Shift by one more place. So if you shift that right side, so here you will get 3, here 2, here 1, here 4. Just one place. Shift in the this way. Okay. Now multiply this with x1n. You will get x3 of 1. So let's just multiply and add. 0 into 3, 0, plus 2 into 1, 2, plus 2 into 1, 2, 3 into 4, 12. Right, 12 to 14 plus 2, 16. So x3 1 will be 16, right? So x3 1 will be 16, or otherwise the another way, so you can write it directly in this way. So first at 0 position at it is 18, second position it is 16. Now calculate at second position. So I am just removing it from here and write down. Now shift by one place and calculate. What will be the value? Any one of you? So just again shift this by one place. So here it will come 4. It will go here 3. It will go here and it will be here. So it is x2 2 minus 1. It is a x2 1 minus n. Right? Now multiply with x1n. So I am writing here now. So you will get, what do you will get? 4 into 0 0 plus 3 into 1 3 plus 2 into 2 4 plus 1 into 3 3. So 3 3 6 plus 4 will come 10. So I am writing here 10. Okay, the next value x3 of 2 is 10. Okay, now again shift one more places. So you will get 1 4 3 2, right? Again multiply with x1 and so 0 plus 1 0, 1 into 4 4 plus 3 into 2 6 plus 3 into 2 6. So what is it? 6 6 12 plus 4 16 16. So next value is 16. Now if you further again shift one place, you will get the same x2 of minus 1. That means the convolution has been completed. Okay, and now four values we have got, that is 18 16 10 and 16. So option A is the correct answer for this question. Okay, okay, so have you understand this question, how to solve this one? Yeah, option A is the correct answer, but you have understand this question how to solve. Okay, okay, so moving to the next question. Now next question is, if x and xk are the 8-point DFT pair, then what will be the x2 plus 8? So already we know that DFT of x1 xn is xk DFT. Okay, so already we know that property of the DFT from the property of DFT x n plus k by the periodicity property, right? X of k. So here n is 8-point DFT. So it is here, it is in a different way it is written. So we have to rearrange it. 2 plus 8. Right? Similarly, we can write it like 8 plus 2. So this is n plus k. So what will be the x of 2 only? Okay. So from the periodicity property. So option C is the correct answer for this question. Yeah. So now moving to the next question. Now next question is, already we have solved this question, this type of question. So can you solve an answer in the chat box? So here it is n is equal to 5 is given, that is 5-point DFT, and 0 1 and 3 values are given. Now for the x of 2 and x of 4 we need to find out. So already we know that by the conjugate property of the DFT, Can you solve and answer in the chat box, please? By conjugate property, we know that x of k is equal to x conjugate n minus k, right? So we don't have x of 2, so first we will calculate x of 2. That means x conjugate 5 minus 2, that means x conjugate of 3. So what is the x3? x3 is 3 plus j, so conjugate will be the 3 minus j. Similarly, we need to find the x of 4. So x conjugate 5 minus 4, that is x conjugate of 1. So what is the value? X of 1, that is 1 minus 2j. We will get 1 plus 2j, right? Now apply the inverse DFT, IDFT. We know that x of n is equal to 1 by n. K varies from 0 to n minus 1. X of k e to the power j 2 pi by n k n. We need to find out for n is equal to 0, that is a 0. So 1 by pi summation k varies from 0 to 4 x of k e to the power n is 0, so value will be 0, that will come 1. So it will come x of k only. K varies from 0 to 4 by 1 by 5. Now it is simply addition of all these values. Just add this 4 at the 0 places, it's 4. Now 1 at 1, 1 minus 2j. At second place, what is the value we have got? 3 minus j. At third places is 3 plus j. At fourth places we have got 1 plus 2j. So is this 2 plus 2j minus 2j will be cancelled out. J minus j will be cancelled out. We will get 1 by 4. 4, 1, 5. 5 plus 3, 8. 8 plus 3, 11 plus 1, 12. Okay. So final answer you will get 12 by 5. Okay. So from here option A is the correct answer for this question. Okay. Okay. So now moving to the next question. So question is given as x1n and x2n are two sequences of length 4 and circular convolution is computed using equation 1, that is the equation 1. Which of the following figure represents x2 2 minus n? Okay. So which figure will represent for this one? Yeah. Can you answer for this one? Can you solve it? So already x1 and will be the, what will be the sequence? 3 minus 0, sorry, 3 0 minus 1, sorry, minus 2 and 5, right? Similarly for x2 and what will be the sequence? At n is equal to 0 will be the 1, and at n is equal to 1 the value is minus 3. Here n minus 2 is not given, that means at that place the value is 0. At n is equal to 3 value is 2. Okay. Now plot x1n. So they are asking simply, okay, x3, okay, yeah, we need to multiply also. So just x1n will be the 3 0 minus 2 and 5. Now simply x2 n, what will be the value? That is here 1, then minus 3 0 2. Now again we need to plot x of minus 2. The next step is plotting minus 2. So just reverse it, that is 1 minus 3 0 2. Now move x2 at this two places. So if you move x2 1 minus 1 n, so here you will get 1, here 2, here 0, here minus 3. Now if you further remove move at one place more x2, you will get 2 minus 1. Okay, so here it will become 0, minus 3, 1, 2, right? So they have simply asked which figure represents x2 2 minus n. So which option will be the correct one? Here option B. So it is matching with this 0, minus 3, 1, 2. Okay, so this option will be the correct one. Okay. It is option B. Okay, so I hope you have understand. So moving to the next question. Now next question is if h of n is the impulse response of the FIR filter of order 62. If and x of n signal of length 320 is applied to the input of the filter, determine the minimum length of the DFT to compute the filter output in the frequency domain. Okay. So if there are two filters, if there is two filters, not two signals, x n and h of n. So in order to determine the output frequency, so already we know that it is simply the convolution of these two signals, x n convolution of h of n, but here it is given x of n is length, let's see its length is n, length of x of n is n, which is given as 320, right? And length of h of n, length, okay, length of and length of, it is given as m, let's see m, it is given as 62. So what will be the minimum length of the output frequency domain, output filter in the frequency domain? So length of the output, what will be the length of the output? Length of the output in the frequency domain must be less than equal to n plus m minus 1. So this one is a one formula. Okay, so here all the lengths are given. So 320 plus 62 minus 1. So here it is less than equal to, so less than equal to 382 minus 1. So it must be 381. Okay, so if there are two signals are given, okay, x1, so their minimum length will be n plus m minus 1. Okay, this one is another formula. Okay, so option A is the correct answer for this question. Yeah. Okay, so moving to the next question. So next question is given, let xt be an analog signal with bandwidth b that is equal to 3 kilohertz. We wish to use an n-point DFT to compute the spectrum of the signal with a resolution less than or equal to 20 hertz. So determine the minimum value of n. What will be the length of the DFT, that is n-point. So here we have to find out that n. Here the bandwidth of the signal is given, resolution is given. Now how we can calculate it? So given B is given, that means bandwidth, that is 3 kilohertz, and resolution is given. Resolution of signal is given, that is 20 hertz. Okay, now we need to calculate, we need to calculate n point of the DFT of DFT. So so I'm giving one formula. Just a minute. So relation between the bandwidth, resolution and endpoint DFT is the relation between bandwidth, resolution and endpoint DFT is resolution is equal to 2 into bandwidth, okay, bandwidth divided by n, okay, where n is the endpoint DFT. So resolution is given 20 hertz and bandwidth is given 2 into 3 kilohertz, so 10 to the power 3. So just put in the form hertz and n, right? So from here you can directly calculate 6 into 10 to the power 3 divided by 20. So further if you just divide and multiply, you will get 2 3s are, so 300 only, okay, right? So option B is the correct. So minimum value of n will be 300. N will be 300, okay? Okay. I hope you have understand this question. Have you got this question? Just remember this formula. Relation between the bandwidth, resolution and endpoint TFT. Okay. Now moving to the next question. So already you have solved this type of question, so you know that how to solve. So can you solve and answer in the chat box? I am solving parallelly. Okay. So here it is a endpoint DFT. So n is given as 8. So it is a 8-point DFT. So x of 0, 1, 2, 3, 4 is given. Now we have to find out x of 5, x of 6 and x of 7 because they are asking for determining energy of a sequence. So already we know that by the conjugate property, by conjugate property, x of k is equal to x conjugate n minus k. So here x of 5 will be x conjugate 8 minus 5. So x conjugate of 3. So what is the value of 3? X of 3, that is 3 minus 5j. So conjugate of that 3 plus 5j, right? Similarly for x of 6, x conjugate 8 minus 6, that is equal to x conjugate of 2. So x of conjugate 2, x of 2 is 0, so that will be the 0 only. Now similarly x of 7, x of 7, x conjugate 8 minus 7, that is x conjugate of 1. So what will be the x conjugate of 1? So x of 1 is 2 plus 3j, so that will be the 2 minus 3j. Now in order to find out the energy of the sequence from the Parseval's theorem, we know that E is equal to 1 by n summation k varies 0 to n minus 1 x of k, mod of x of k square, right? So directly if you put x 1 by 8 summation k varies 0 to 7 mod x of k square, okay? Now 1 by 8 summation of all these values. So I'm removing it from here. Okay. So I'm not able to remove it from here. So just take all these values. So x of 0 mod square plus x of 1 mod square plus till x of 7, right? Square. So 1 by 8 in bracket. X of 0 is mod square. So it will be 9 plus in place of 2 plus 3j. So mod of 2 plus 3j already we know that root of 2 square plus 3 square, that is 4 plus 9. So root of 13. So root of 13 square will be the 13 only. Now x of 2 square. So that is 0. X of 3 square similarly. So 9 plus 25. What we will get? 34. So 34 square will be the 34 only. Right? Plus 36. 6 square. Root of x of 4 square. Sorry, root of no x of 4 square will be the 36. Now next x of 5. What we have got in place of x of 5? That is 3 plus 5j. So 3 plus 5j already we know that is root 34. So it will be the 34 only. Now x of 6, right? X of 6 is 0. So 0 only. And now next x of 7, that is 2 minus 3j. So 2 minus 3j will be 13 only, right? Now add all these values, you will get 9 plus 13, 22. 22 plus, if you add all those things, you will get 139. You can add it. So 139 divided by 8 is the correct answer for this question. Okay, that is option A. Now moving to the one and last question, that is 20. If W400 that is equal to Wx200, then what will be the value of x? So you know that what it is called, that is W and Kn. It is called Tweedle factor, right? In the DFT, Tweedle factor. So it is in this form. Okay. So this is equal to, we know that e to the power minus j 2 pi by n k n. It is represented in this form. So if we write W400 in this form, what will be the e to the power minus j 2 pi by 4, right, into 100. Similarly, if we write Wx 200 in this form, so you will get e to the power minus j 2 pi by x, because we don't know the value n and into 200, right? So already it is written W400 equal to Wx 200. Just putting the by this, so you will get e to the power minus j 2 pi by 4 into 100 equal to e to the power minus j 2 pi by x into 200, right? So exponents are same, then it will be hold equality condition. So all these things, if you further do that, that will be the cancelled out. So 2 pi by 4 into 100 equal to 2 pi by x into 200, right? So this one will be cancelled out, and this two zeros will be the cancel out. You will get x is equal to 8. 4 into 2, 8. Okay. So x will be the 8. So option C is the correct answer for this question. Okay. Yeah, option C. So option C is the correct answer for this question. So these are the some questions for this week related to this week video content. So now the questions have been completed. If you have any doubt, you can ask. Otherwise, we can close the session. So yeah, thank you everyone. Thank you for joining this session. Now, if you have any doubt, you can ask. Otherwise, we can close the session. And regarding that questions I have noted down, I will ask from the concerned faculty, or you can uh, see in the forum section, that discussion forum, or you can directly see in the assignment. If there is no changes, then I think grace marks will be given. Okay. So okay, now you can leave the session now if you don't have any doubt. Can we close the session? Yes. Okay, so thank you everyone. Thank you for joining.
Yes, ma'am. Thank you.
Yeah, thank you. You can leave the. Okay, everyone. Thank you for joining this session.